Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at lesson 5.1.2. This is going to build on the processes that we were learning in lesson 5.1.1, finding percents or percentages of a whole, finding the parts, or finding the totals. What we're going to do now is we're going to look at some situations and create diagrams for those situations, and then we're going to take a look at a resource page, which you can print off from the Google Classroom or from the online book. It's attached to that as well. And I would highly recommend you actually do print that off. If you don't have the means to print it off, then just take some time and sketch these diagrams, because it's really important to have them in your journal. And this analysis that we're going to do today is, I think, going to be very beneficial for you moving forward when you need to solve various percent problems. So let's read through the intro. It says, how are sales advertised in different stores? In clothing stores, or in a clothing store, items are often marked with a sign that says 20% off or 40% discount. In grocery store, sale items are usually listed by price. For example, pasta might be marked as 50 cents the sale price, or $2.33 each for a box of cereal. In a clothing store, you're able to see how much the discount is, but the price is not often listed. Whereas in the grocery store, they don't give you the percent of the discount, they just give you the new sale price, right? Okay, and if you're expecting me to read through this and read it word for word, I'm sorry. I've just read this so many times. I'm into paraphrasing the stories, so you get the essence of it. So I apologize if you're tracking these words and listening to what I'm saying, and I'm not saying the same thing that it says right here. Okay, so in the actual dollar amount of the discount and the percentage comparing it to the whole are important pieces of information that help you decide if you are getting a good deal. Today, you will create complete information about a sales situation from the information given within the problem. So by the end of this lesson, you will be expected to answer these types of target questions. How can I find a percentage of a whole? How can I find a percent if I have two parts that make up whole? And how can I find the whole amount if I know the parts? All right, so here's a situation for problem number 14. Marissa is always looking for a great deal while shopping. She found a rack, or a sale rack, where all the jeans are marked off 40%. Her favorite jeans regularly cost $65. So to figure out if she has enough money to buy a pair of jeans, Marissa decides to use her estimation skills. She thinks that the jeans will cost about $30. Is that a reasonable estimate? All right, so while you're thinking about that, I want to point out what I'm doing right here. Anytime I see these problems that involve percents, especially if it's a nice round number of a percent, like 25% or 30% or 40%, I like to do some estimating or some mental calculation, I guess would be the right way to put this, for some of the benchmark percents. For instance, if it regularly costs $65, you know that that represents 100% of the price, correct? That's the total it would normally cost. And since I know how to find 50%, since that's just half of a number, I'm going to mentally figure out, all right, what is 50% of 65? If this were half off, it would be $32.50, right? And if it was 10% off, 10% of 65 would be 65 divided by 10, where you just move the decimal one place to the left. So finding 50% and 10% is usually fairly easy, because most people are able to figure out half of a number and divide a number by 10 without too much trouble. Okay, so with that being the case, if I was going to try and figure out what 40% off would be, I would take the 10% and multiply that times 4. That would be the amount of the discount. Okay, so now let's come back to this. She thinks that her cost is going to be about $30. Does that really make sense? And so if she is paying, if it's 40% off, doesn't that mean that she's going to pay 60% original, right? Think about that. And look at this diagram down here. This represents 100%. 40% is the discount, which means she's going to be paying the rest of it, which would be 60%. So if 50% is $32.50, wouldn't 60% be somewhere around $38 or $39? Because you would add the 10 and the 50% to give you 60%. So I don't think that's right. I think she would have to pay more than half the price, not less than half the price. So 30 is less than half of 65. So that's probably closer to how much her discount is, not how much she would be paying. So problem B says to find the exact answer, Marissa created a diagram below. How could she add marks to partition the line evenly? And so if you look at this, doesn't it seem logical that she would break it into 10% intervals? So you'd take 100% and break it into 10 equal parts, and each part would be 10%. So what I would like for you to do is this. I would like for you to copy down this number line and pause the video and then figure out what would 10% of the total be? We've already got this up here, right? So if you broke this up into 6 equal parts here, how much money would she pay? And if you break that up into 4 equal parts, how much money would be the discount? Okay, so go ahead and complete this table. And we know the total corresponds to the 100%. I'm going to go ahead and remove that right now. We know the total is already $65. So all of these parts have to add up to 65. Okay, so go ahead and see if you can fill in these two quantities based on what we've done here and based on what we've been talking about. I'll pause and give you a chance to do that. All right, so this is how I figured these quantities out. Now I'm going to show you a couple of different methods and how you would figure this out. First of all, using the whole mental math strategy. If you know that 100% of the total is 65 and 50% would be 3250, and if we take and divide this into 5 equal parts, it's 650, but it seems more logical to say 10% would be 65 divided by 10, so it'd be 650 as well. So if you multiply that times 4, that's going to give you the 40%. And so 4 times 650 is $26, so that's got to be this quantity right there. 40% of the total is $26. And then if you multiply 10% times 6, that's going to be your 60%, which is going to be $39. So that's the quantity here. So how much will she save? She'll save $26. What will be the price that she will pay? She will pay $39 for this particular pair of jeans. So it says that Marissa wants to check her answer from part C. How could she use ratios with the amount she saved and the original price to verify that she received 40% discount? Well, remember, this is where we could use proportional reasoning, where we don't know how much the savings is going to be, but we know it was 40% off. So the total was 65. So we are going to set up this percent proportion. So if we plug in the 26 here, and we can prove that those two are equivalent to each other. Okay, so let's go ahead and do that. If we want to prove that these two ratios are equivalent to each other, we can simplify both ratios to their simplest form, or we could change both of them to decimal numbers, or we can convert both of them into percents, or we can do cross multiplication, and that's what I'm going to do. Remember, the whole essence of cross multiplication is based on the idea that when you have two fractions that are equivalent to each other, their cross products will be equal to each other. So if I take 40 times 65, I should get the same answer as 26 times 100. So I know this is going to be 2,600. Let's verify that this is going to give us 2,600. So 40 times 65 is 2,600. That is correct. So the fact that those two are equal to each other proves that these are correct, that these are equivalent ratios, which proves that our numbers up here are exactly correct. All right, now let's try another situation. At the same time, Kirsten sees a shirt on sale for $37.50. It originally cost $50. Okay, so here's one where we're going to estimate the percent. Now, I would say the percent of the discount. Okay, so it's on sale for $37.50, which means that the discount would be about $12.50. So that is close to, that's like 1/4 of that, right? Because if you double this, that's going to be 25. So yeah, I think this is going to be about 25%, at least between 20 and 30%, somewhere in there. But we'll figure out exactly what it is by using our different strategies. Okay, so we can start by drawing a diagram to represent the situation. So here's how our diagram can look. We can break it up into 10 equal sections. I chose to break it up into 20 equal sections, making each one of these 5%, each one of these 10%. So if I take, and we know that this is 50, then 10% of 50 is going to be 5, then this should be 10, this should be 15, this should be 20, this should be 25, right? Because half of 50% is 25. This should be 30, this should be 35, this should be 40, this should be 45, and this should be 50. Okay, so every 10% is equivalent to $5. Okay, which means that 5% would be $2.50, right? That would be your 5%. So if this is marked off, no, if the sale price is $37.50, then that means, let me go ahead and use a highlighter here, $37, so you go all the way up to 35 and then another 250. This right there would be $37.50. Right there. So what percent would that be? 10, 20, 30, 40, 50, 60, 70? That's got to be 75%. So this quantity from here to here, she's paying 75%, which means that the amount of the discount has to be the rest of it, which would be 10, 20, 25%. So I estimated that the discount would be somewhere between 20 and 30%. Turns out the discount is 25%. Okay, now let's go up and use my mental strategy to solve this problem. Let's take 100% is $50, right? And that means that half of that, 50%, would be $25 and 10% would be $5. So if I try and figure out how to get my total amount and my total savings, I might take a 50% plus a 10% plus another 10% plus another 5%, right? That would be your 75%. So that would be $25 plus another 5 plus another 5 plus another $2.50. I'm going to go ahead and put in my decimals there. And this ends up being 15, 16, 17, carry the 1, $37.50. So that means that 75% is equal to $37.50. That's the amount that we paid, which means the rest of it would be the discount, which would be your $12.50, because 50 minus $37.50 is $12.50. Okay, but I don't think we asked for that question. What does it say? What is the relationship between the discount, the sale price, and the original price? Write a statement that shows the relationship between the sale price, discount, and original price. All right, so hopefully you've got some experience here with going shopping and understanding how discounts work, right? The sale price is how much you pay after you apply the discount. The original price was what you would normally pay if they weren't discounting anything. So how do you get to the sale price? What do you do with the discount? Well, hopefully you are saying right now on the other side of this video, you take your original price and you subtract away the discount. After doing that, you get your sale price. So $50 minus your discount gives you your sale price. And for that matter, if you took your original price minus the sale price, you would get the amount of your discount. So it's kind of like those fact families going back and forth. You could have also stated that the sale price plus the discount gives you the original price, right? So the sale price plus, or the sale price plus the discount would equal 50 in this particular situation. All right, so now is where we're going to take this resource page. And this is what we want you to do. It says we're going to write at least 3 statements describing how parts and percentages are related. And in this particular worksheet, you've got a total of 5 different situations, and they're shown as A through, oh, maybe there's 6, A through F. And the statements are started on the right. So this is what I need for you to do. This is going to take a little bit of time. We're going to pause this video, and you copy down all of this information or print it off, and go ahead and fill in the missing parts. And I'm going to go ahead and model A for you so you know exactly what we need to do. Okay? So for part A, looks like the total is 30, correct? And it looks like it's partitioned into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. So we can figure out that 10% of 30 we know is 3, right? Which means that each one of these parts has to be equal to 3. So I'm going to write that in. Right? 3 times 10 is 30. So this quantity here, which represents 20% because it's 2 intervals, 20% must be equal to $6, correct? So that would be 6. And this part is 1, 2, 3, 4, 5, 6, 7, 8. That's 8 times 3 is $24. So that's going to be the statement. So what percent does this have to represent? If this was 20, the rest of it must be 80%. So we're going to finish out that statement by writing in 80% of 30 is 24. Okay? So eventually, we're going to follow these models here to help us. And then eventually, we're going to get to the point where we can just write our own statements down here. Okay? So take some time, look through these. I recommend you start by looking at the known information and the number of equal parts it's been broken into, and assign a number to each one of those equal parts. Then look at the total number of equal parts in the entire line to figure out how are they partitioning this. Are these 10% intervals? Are they 20% intervals? Are they 25% intervals? What kind of intervals are they? And then fill in all the necessary information here before coming over here and filling in the blanks there. Okay, go ahead and pause. I'm going to pause, and when I unpause, I'm going to have us go through every single one of these parts. All right, let's take a look and see what we've got here. And let me choose a different color there. No, 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 no. Yes, I like that one. Okay, so here we go. Let's go ahead and slide this guy down. We've already seen the work here for problem A. Change the colors around a little bit for you. Mix things up. All right, now for B. These are the statements that I have on the right. And what did I do? I broke this guy up into 3 equal parts. Each one of these has to be equal to 6, right? So all 3 of them equals 18. Because the total is broken up into 4 equal partitions, then that means that you're counting by 25% intervals. So these 3 make up 75%, and this one makes up 25%, which is the 4th 6. So you know that the total must have been 24 in this situation, because 4 times 6 is 24. So that means that 25% of 24 is 6. 50% of 24 would be 12, and 75% of 24 is 18. If I go too fast, please pause, and you can pause at any time you want. I'm just going to move through it to get this over with. We don't want a 40-minute video. All right, so here we go. In this case, the 24 was the total, right? We've got it listed here. And it's broken up into 5 equal parts, which means that each one of these intervals represents 20%, right? 20, 40, 60, 80, 100. So I'm going to take 24 and divide it by 5. That's going to give me, each one of these intervals would be 480. Or I could think, if I know that 10% of 24 is 240, or 2.4, I should say, $2.40, and 20% would be twice that amount, which would be $4.80. So each one of these is 480. So 3 times 480 is 1440, and 2 times 480 is $9.60. And double check by adding these guys together to verify that they add up to 24, and they do. So 40% of $24 is $9.60. 60% of $24 is $14.40. And any other statement, you could have said 10% is $2.40. I chose 20% of 24 is $4.80 because that's kind of what I've got labeled right there. All right, this particular one is broken up into 20 equal partitions, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the halfway point, I think. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes. So this is a little bit trickier because we have to figure out what are each one of these intervals going to be equal to. And since it's labeled here as $66.50, it's partitioned into 19 equal parts, I decided to take that number and divide it by 19 to determine that each one of these individual parts here is equal to $3.50. So you can verify that by taking $3.50 and multiplying it times 19. 3.5 times 19 is indeed equal to $66.50. So if every one of those is $3.50, that means that if you add another $3.50 onto the $66.50 plus $3.50, that gives us a grand total of $70. Okay, so we know the total has to be 70 in all of these statements. So how do you want to break those statements apart? Well, we know 95% of 70 is 66.50. That's what we've got shown right here. So we know that the 5% has to be 3.50, and then choose any other percent you want. You didn't have to necessarily say 10% was 7. You could have said 50% was $35 if you wanted to. You could have said anything. I just chose a relatively simple one. 10% of 70 is 7. Okay, now actually, let me just show you something here. This is one where, oh, I locked it in, didn't I? Okay, let me put on a little dry erase kind of a board here. Okay, let me show you this. This is the part, right? $66.50, where that represented 95% of the total. So we need to put X here for our total. That's supposed to be a 5 right there. So if you use your proportional reasoning, I would probably multiply this times that. So you go to the cross multiplying. 95x is going to be equal to 66500, right? Move the decimal to, oh no, only one of those. Okay, so you move the decimal 2 places to the right because you're multiplying times 100. So now when I take 6,650 and divide it by 95, I should get the total. $6,650 divided by 95 is going to be 70. So that means that X, our total, has to be 70. Sorry about that little tail there. I can't fix it. That's fine. So basically, you can use different strategies, and if you like the percent proportion, eventually just go ahead and do that. But for this exercise, let's continue with this process here. Let me get rid of that guy too. Okay, here we go. This problem, how does this appear to be partitioned? Well, it looks like this section right there is 30%. So if we broke it up into 3 equal parts, now what would we have to do there? Each one of those is 10%. So we know each one of those has to be a 12, doesn't it? Since we know that 10% of 120 is equal to 12. So here you're going to have 3 times 12 is 16, and here you would have 7 because the rest of it has to be 70%. 7 times 12 is equal to 84. So here we go. We know 10% of 120 is 12. 30% of 120 would be 36, and 70% of 120 would be 84. Now I can add these guys together to prove that our total is 120, because 30 plus 70 is 100%. And 36 plus 84 is equal to 120. And then our last one. So it looks like this is 85%. So I would probably want to figure out what 5% is equal to. Then I can triple it to figure out what 15% is equal to. So what information do we have? we know if this is 85%, then this has to be 15 because the total have to add up to 100. Excuse me, have to add up to 100%. So that means that 3 equal parts, when partitioned and added back together, would equal 450. So what does each one of those parts have to be? If we take $4.50 and we divide it by 3, we will get $1.50. So that means that if 15% is $4.50, then a third of that, which is 5%, would be $1.50, which means that if we take 2 of them, every 10% is going to have to be 30. No, 3. It's going to have to be 3. So if I take 10 of these, that would be 100%. 10 of those gives us a total of 30. So there we go. We know that the total 100% has to be equal to 30. All right, now let me go ahead and show you using proportional reasoning how I would get that piece of information. I know that $4.50 is the part. What I don't know is what the total is. But this represents 15% out of 100. So we're going to cross multiply and get 15x is equal to $4.50 times 100 is 450. And then when you take 450 and divide it by 15, 450 divided by 15 tells us that x is equal to 30. So that's how we figure out what the total is. Now that we know that the total is 30, we can declare that 15% of 30 is 450 and 85% has to be the rest of it. So 30 minus 450 is 2550. And then we know that 10% from what we did over here must have been equal to 3. Okay, so that pretty much is proportional reasoning. If you've been given 2 parts, you can always figure out the third by setting up a diagram, by using a little bit of logical reasoning, or by using the percent proportion. And as we move forward, we're going to start getting word problems that involve decimal numbers and decimal percents, where we set everything up the same way, but then we rely on our calculators to do the heavy lifting and to solve our problems for us. Okay, all right, so less than 30 minutes, good. I thought this one might be over 30 minutes like the previous lesson, but it wasn't too bad. Let's move on to our next phase, which I'm thinking is going to be a check for understanding, and then let's do our homework. All right, take care, bye.
Hey, feeling good, like I should.